this video, I would like to take a topic from 10th standard Samacheer kalvi and cbse plus 1, and the topic name is composition of functions. So by seeing the topic itself, you must know this composition of functions is related with the functions. So before starting the class, I would like to keep one point here now. Composition of function happens among the two or more than two functions. And also I would like to bring this concept in our real life. Okay, so the thing is, it's just like machines which are used in the factory. Okay, for example, I have mango juice factory, and if I want to prepare mango juice, what are the procedures? Raw mangoes we need, then that raw mangoes we have to clean first. How to clean? We have to keep in the one machine first. Okay, after cleaning these mangoes, all the clean mangoes will send it to the another machine to make the pulp. Then after making this pulp, what to do? All the pulp will be sent to the another machine to get the juice, right? Then after it will be going on. After getting juice, we have to mix with the chemicals or something to preserve the juice. Then we have to put sugar and all. Then we have to fill in the bottle. Then labeling and the capping, all this are done by the machines. So these machines are nothing but it's just like a function. Okay, so now as I told you that this first step, what we can remember here means these raw mangoes are nothing but this is the input. Okay, input is nothing but the first element x. Okay, x is the mango. Now mangoes are denoted by x. This is called input. Then these mangoes we will put in the first machine. So this first machine is nothing but function f. Okay, then if this input is put in the machine, we will get one output. That output is called pulp. So this is called f of x. Okay, you understand now? Input, now putting in the machine is nothing but function, first machine. Okay, then we will get the pulp. Pulp is nothing but f of x. Okay, then in the second step, what do you pulp is the input. Now for the second, in the second step, for the second machine, this is the input. So this input is nothing but f of x, right? Pulp means what is that? F of x. Okay, so this pulp will pour into the second machine. So this second machine is another function that is called g. Okay, f of x will be poured into the second machine g. Then we will get juice. Now this juice is called g of f of x. Okay, so last this output is called composition of functions. What are the functions? F and the g. This is the product. Okay, this is the product of after what is that? Feeding. After feeding all the elements to the first function, then one output will come. That output is feeding into the second function. Then we will get one output here. This last output is called composition of function. Now let me come to the point. Definition of composition of functions. Let f is the function from a to b, and g is the function from b to c, are two functions. Then the composition of f and the g is denoted by OF and is defined as g of f of x is equal to g of f of x, where for all values of x belongs to A. So if I write the definition, you won't understand easily. So the first of all, you must know in the three sets, A, B, C are three sets now, and also there are two functions, A to B one function, B to C one function, and these two functions composition is denoted by GOF and is defined as GO f of x is equal to G f of x, where for all values of x belongs to A. Okay, meaning is here the first input, as I told you in the example, in this function the first input should be from the A. Okay, then if I feed this x in the function f now, we will get f of x. Then that f of x again will be feeding into the another function g. Okay, then we'll get the g of f of x. So that g of f of x is called composition of functions f and the g. Okay, so for example, this is one matching. Okay, this is the g, this is another matching. So now I took a element is x. This x element we will fit in the matching. Okay, what we'll get? We will get f of x. I mean, if we put this x value here now, we'll get one output here. That output should be belongs to B. Suppose after putting this x value here now, if the answer is not belongs to the B, then we cannot make the composition. So always, if I feed this x to the f now, we'll get f of x, this output. This f of x will be belong to the B. Otherwise, no composition. Then again this f of x will fit in the g. We'll get g of f of x. So this will be, this last product, last output is called composition of function. So this is called, this function is called composition of function. Okay, GOF, composition of function G and F. Okay, so if you don't understand this one, I will tell you with example. Suppose this is a mango now, raw mangoes. This mango I will fit in the first machine, will get pulp. Then again this pulp I will fit in the next machine, will get the juice. So this juice is called composition of the two machines. Why? How we are getting this juice? After using these two machines. Yes or no? Then what are the inputs here now? The first input is raw materials. What is that? Mango. Mango is the first input. Then pulp is the output. After mango is putting in the machine, pulp is the first output. Then this output again. Suppose if I put the mango here now, if pulp is not coming, means we can't make the juice now. So that's like that. If x is feeding here now, we'll get f of x. This f of x compulsory should be in the B elements. Okay, B set. So this is called composition of function. This composition of function, two functions can be completed in two steps. Okay, composition of two functions can be completed in two steps. The first step already I told you here now. First, feed the input x in f. Okay, to get f of x. Then feed again now this f of x into g to get g of f. Okay, so like this, these are the two steps should be followed to find the composition of any two functions. Okay children. Okay. Properties of composition of function. First, You know already commutative property, associative property. So composition of function is not commutative always. Okay, sometimes it may be commutative, but sometimes it may not be commutative also. Okay, it's not composition of function is not commutative always. Meaning is FOG is not equal to GOF always. Okay, sometimes it will be equal. That's why I mentioned here now always. Sometimes it will be equal also. Next one, composition of function is always associative. Meaning is FOGOH is equal to FOGOH. Both should be equal all the time. Okay, and the third one is composition of G of F exists only when the range of F is the subset of domain G. If I put the mango in the first machine, we will get the pulp. Suppose if the pulp is not making at all, then we cannot make the juice. So like that, if the first input is put into the first function f, we will get f of x. That f of x should be the subset of second set. Second set is nothing but b. Then when it is the subset of second set, then we can consider as input for the next function. That time only composition of function will be exists. So let us see some question. First, let me find out left hand side. What is the left hand side? FOG. FOG is nothing but f of g of x. F of g of x. What is the meaning here now? The first what we are going to do is, in the g function we have to fit the x. In the g function we have to fit x. So what is g of x now? X square. G of x is already x square. F of what will come now? Here x square. Okay. Now again what you are going to do is, this is just like f of x now. So f of x means what is the formula? X minus 6. Okay. F of x is x minus 6. Yeah. First you leave like this now. Just consider this is just like f of x. Whatever the element may be coming here now, f of x you have to consider. F of x means what is the formula? X minus 6. X minus 6. But in this, what is the x value now? F of x. So this is x now. Suppose here 2 given means x value is 2. You have to write 2 here now. 3 given means you have to write 3. Here p given means x value is p. So you have to write p. But now here the x value is x square. So your answer will be x square minus 6. You understand, children, now? Then let us find again right hand side. G O F. Meaning is G of f of x. G. Already we know f of x value is x minus 6. Okay. So now it becomes g of x. So this is just like x now. G of x. Okay. Here the x value is x minus 6. What is the g of x formula? X square. X square. Okay. So g of x value is x square now. X square. But what is the x value here? X minus 6. X minus 6 whole square. So x minus 6 whole square. This is the right side answer now. I told you how to apply this one. This is just like g of x. Whatever x value is coming here, you should apply in the x. Okay. Here 2 given means you have to write 2 square. 3 given means you have to write 3 square. Now here x minus 6. So you will write x minus 6 whole square. Okay. Now you just see, this is the left hand side answer now, and this is the right hand side answer. Both answer same or not? No. Left hand side is not equal to right hand side. So from this example sum we can learn f of z is not equal to g of f always. Okay, now let's go to the next question. So let me find out left hand side first. Left hand side is f o z o h. So first we'll do the bracket f o z. F of z means what is that? F of g of x. I'll write in the one line is still okay. F. What is the g of x? G of x value is 3x plus 1. Now it becomes f of x. So this is x now. F of x, what is the formula? X minus 1. What is the x value here now? 3x plus 1. So 1 minus 1, 0, answer will be 3x. So f of z value is 3x. Last part, f o g o h we want to find. Here the meaning is f o g, that is x. First you write f o g itself. Then hx how much now? Hx is x square. So what is the f o g value here now? F o g value is 3 f o g x. Okay, f o g x now. So f o g value is 3x, 3 into x. But what is the x value here now? X square. So 3x square is now right hand side. F o g o h. First find out g o h. G h of x. G h of x is x square. Now it becomes g of x. What is the g of x formula? 3x plus 1. 3 x value is x square plus 1. So 3x square plus 1. Now f o g o h, meaning is f g o h. So f g o h value is already 3x square plus 1. Then fx, this become fx now. Fx value is x minus 1. So this is the formula, okay. Fx value is x minus 1. So what is the x value here now? 3x square plus 1 minus 1. So minus 1 minus 1 cancel. What is the answer now? 3x square. So we got the answer here. Okay. So once again I will tell you. First, in this left hand side you find out f o g. This one somewhat easy only. Next, f o g o h. Meaning is o h. This hx will be there, no? That hx value will be feeding into the f o g. F o g hx. F o g hx. What is the f o g formula? F o g formula is 3x. Okay. F o g of x means f o g formula is 3x. Now we got here f o g is 3x. Then what is the x value here now? X value is x square. So like this you can find out. Then this part easy only. This one only little bit confusion children. So you have to be very careful this part. Okay. So I hope you understand the sum. This is how we are going to find the f o g, g o f and the commutative property, associative property. So I will teach you in the next class some more questions. So for today, goodbye children.